Hello, welcome back to BLENDERSUSHI live noding. So from previous video, I show you how you can think about FCurve and think about how the time is controlling the value using sphere chokes and then also animation nodes. And then now we are trying to kind of break up a way to control a single FCurve using multiple time offset, and the result is something like this. So this is the setup from previously, where we have the monkey and then the torus kind of growing and then growing up and then growing down, scaling up, scaling down, and then here we have like a multiple torus, right? And then I'm kind of controlling the scaling up and scaling down for multiple of them at the same time. How did I do that? So let me stop it, go back to compositing, and then this is actually what we have. It's rather quite simple. So this is the original setup that we have. We have the empty that's kind of animating up and down. It's going it's translating in the Z from 0 to 1 and then stop at 1 and then goes back to 0. It's kind of like a very linear motions, but it's very useful for motion graphic. So that's one setup. It's for this torus. Actually, I'll give it a color. So that pink torus is being controlled by this guy in animation nodes, while this monkey is being controlled by sphere choke. Okay, the green monkey is being controlled by sphere choke, and then we have this blue color donuts that's being controlled by all of this stuff at the bottom. It seems complicated, but don't worry, it's actually rather simple. Everything else is like here, the nodes that I didn't use. What I did was kind of searching for FCurve and then all these curves coming out, and then the one that I really use is this evaluate FCurve. I can start from scratch and then let's see how this actually being created. So let's save this and then save as new. I'm gonna delete object instancer and then delete the donut. So we still have the animations of the pink donut and the monkey, and we have the buffer empty. Everything else I will actually just delete. I'll start with the nodes called evaluate FCurve. So this is the key to do like a offset of FCurve. Let's create icosphere for now. Okay, something different. So we want the icosphere, but we want multiple icospheres to kind of show the offset of animation. We're gonna do only one icosphere, but we're gonna grab the animation from this empty first of all. Object what is it? FCurve. See, FCurve from objects. That's what we want. Grab our empty, and then we have our FCurve. You will see it's actually like a multiple FCurve because because you can have multiple FCurves from an object. We don't know what it is, but maybe it depends if you have like XYZ of the scale of XYZ of the translate or whatever. But at the moment we only have one from index 0. So let me try this one first and then use a normal time frame, plug into that guy, and then grab our icosphere, object transform output, the icosphere, and then control the scaling. Let's see what's happening. Okay, looks like we have something that's similar like before, except that this guy is slightly being offset, which is which is interesting. Maybe instead of offset, we want to use absolute, and then this is, I think it's much easier to understand. So now the time is controlling it, but the absolute means this is like the original times. If we use the math to add like to add a number, to add a value into our time, so now we are kind of offsetting the time. You can see, okay, maybe I offset it like 50 frame. So now this guy is being offset 50 frames, you know, like what we specify here. So compared to the original animation driver setup, this guy is being offset 20 frames. So that's cool. That's exactly what we actually need in order to have like a multiple objects and then multiple offset. So let's grab this guy, and we're gonna use object instancer. Let's have like 10 instance of the icosphere. Give it a color so it's easier to see, and we don't need to change anything else. So let's create a loop. Now with the loop we can create first of all we're gonna place the icosphere in different spot. We can use a random vector, index plug into the seed, and then vector into the locations, and the objects into that guy. So now we have the copy of our icosphere at different place. I'll grab the master and put it somewhere else. So the instance is doing the animations like before, but we want to kind of offset all the animation, right? So how do we do that? We just need to plug in a random value to this add. We can use the index first of all. You can see that now they are kind of offset by one frame. If we use math and multiply the index like 5, we can see from the first instance object to the last, it has a little bit of offset. This is kind of nice. Actually, for a lot of motion graphic animation, this is the very basic, and sometimes this is actually what you need. You don't need anything else. You just need to randomize the offset, randomize the timing of multiple objects, make like a 100 objects, and it looks quite nice already, you know. Animation can do it pretty fast if you hide the node editor. See, this is like almost like a full FPS perhaps. So instead of using the index and the multiplier, we can use the random number. So random number, plug the index to the seed, minimum maximum maybe minus 50 to 50, and then plug in the number into this multiplier, and then now all our objects kind of doing this loop of animations. It's all actually being controlled by our empty, remember? So this is really cool. Even though this is like a basic concept, I'm kind of repeating it just for us to fully understand it. I need to break this video tutorial into 3. Like, remember in previous live noding, I did a grease pencil, drawing the curve, and then being sampled, interpolated in Spreadshop. That's actually kind of like the reverse of what's going on behind the screen when computer is evaluating an FCurve. Now we are using animation nodes, and then animation nodes have the convenient nodes to kind of a sampling like a FCurve from an object and then reusing it for other objects. That's really the basic of kind of a offset of animations in motion graphic. So you see the donuts and the monkey is doing the original animations. The rest of them is doing this random animations. In fact, if you want to do more, currently the scale is all the same. You can also randomize the scaling, the value of the scaling here. You can let's say use some math and then multiply it with a random number from this guy. Actually, have another random number index and then multiply it with a value of this and plug it into that guy. You can also use noise, by the way, not just random. Random is often too random. You see, now every sphere is a kind of random size. I believe you can have 1000 of this and it's still pretty fast. 1000, or actually 1000 is already kind of a lot. Just be careful. It starts to slow down over 1000 because it's 1000 objects. Blender doesn't like 1000 objects. Blender likes a single object with a single objects but 1 billion points maybe, and then instance the particles and control the particle scaling is a lot faster than 1 billion objects. 1 billion objects and Blender will die. Of course, 1000, 10,000 of objects are already pretty difficult, but 1000, 10,000, 100,000 particles or a single object with 10,000 vertices is much faster than having 10,000 objects. Yeah, hopefully that's quite clear. So 100 objects, no problem. It's full speed. Okay, so that's pretty much what I want to show you in this live noding. It's an offset of FCurve using animation nodes. In the next live noding, I might try using sphere chalk to do this. We'll see. Okay, I'll see.